To the Bureau of Energy Efficiency, the refresher guide to the energy manager and auditors. You can see the curve, the graph, the percentage speed versus the percentage power and torque on any variable torque load. Maybe it's a centrifugal blower or a axial flow fan or a centrifugal pump in the utilities. These are all the variable torque loads, and these loads, like especially the blowers and fans, they need much lower torque at lower speeds than at high speeds. This is the focus area which you are trying to achieve the energy savings now. Elaborating more on the variable torque loads, the VFD is used for the variable, mandatorily the VFD needs to be used for a variable torque load for a blower or fan especially. The VFD is used in the blower and fan can optimize the torque between the motor and the load, and as well facilitate the blower to run at an efficient band of its FPS, fan performance curve. The image sourced from LinkedIn, and it clearly shows that at 100% of the load, you can see the torque is 100% and the speed is also 100%. Whereas at the 50% of the load, the blower, you can see the torque is only 25% of the full load torque, and the HP is only 12.5% of the full load brake horsepower of the blower. This graph indicates clearly the gap between the supply and the demanded torque from the motor to the blower. Basically, the blower is a variable torque load which we are trying to utilize here. This is the area which is not focused at all till now, and it is high time that we have to focus this area and achieve the energy savings instantly and affordably. Thousands of case studies have been done in this region, and with cogged belts and VFD and redesigned pulleys and belts to exercise the proof of achieving this energy savings and reducing the torque gap between the supply and demand torque from the motor to blower. Coming to the case study of this, you can see it's an automobile major based at Chennai, and it is done in an air handling unit in the year 2024 by our MSB team. It's a 7.5 kilowatt motor, VFD operated. You can see the before study, before replacing the belts and pulleys, at 50 Hz you can see the blower RPM is at 80 RPM, and the energy consumption is almost 5 kilowatt, and after redesigning the belts and pulleys, and you can see the motor is operated at 43 Hz, but the blower RPM is maintained at 880. See, the conservation means for the given output, what is the input reduction that is possible? This is what it is achieved here. For the same blower output RPM, 880 RPM, the input reduction has happened from 5 to 4.2, almost 16%